Welcome back to the workbench here on Dylan's DCC. Today we have this nice vintage, I'm guessing 1990s based on the plastic side frames on the trucks and the overall condition of it. Athearn Blue Box GP35 for the Chicago, Burlington, and Quincy, number 989. This locomotive belongs to a friend of mine. It is a DC locomotive, has not been converted to DCC. However, his layout has been. Oops. Sorry, didn't mean to zoom in there. Just was making sure I was zoomed all the way out, because it looks a little funny. I think I need to pause for a moment and adjust my camera. Alright, that's a little bit better. So, this engine, as I was saying, has not been converted to DCC yet. However, his layout has been. So, today we are going to install this. I don't know if I show you there through the package. There's a little bit of reflection because this is a Mylar package for anti-static protection. Don't know if you can read that. It looks like yes. This is a TSU-1000GN, which means it came out of a Genesis, Athearn Genesis unit, EMD 567. The engine that this came out of likely belonged to a customer of mine who upgraded his entire fleet to half ESU and half Soundtrack Tsunami 2s. But he went with the retail versions, not the Athearn Genesis specific units. So this will be a reuse. This is pre-wired up for everything. Already all the correct NMRA color code color wires coming off of it. However, the blue common wire here is going to have to be changed. The reason for this is because Athearn, in their infinite wisdom, decided to use 1.5 volt incandescent bulbs for a very long time. Those bulbs are junk, but because of them, that positive common pad, is 1.5 volt pad. So we have to connect it to this little hole here, which is plus 14 volts. And I have a low battery on the camera. I shall return after I change it. Alright, nice fresh battery installed. So let's get back to the job here. Push those excess wires out of the way. I've got a pile there that I haven't sorted into their pill bottles yet, where I keep my wire scraps. So, as I was saying before I had to change the camera battery, we are going to have to move this blue wire from the positive common pad, which is only 1.5 volts, over to, let's grab something smaller to point with, and get this flipped around the right way, right there, where the camera won't focus on it, of course. That little pad right there, that little ring pad, is a plus 14 volt common. Now there's another one over here that is a common ground that I don't know why they included, because everything DCC is positive common. You cannot convert any of the function outputs to positives, so there's no real reason to have a ground, except if you're going to hook up a current keeper, which I don't do. I mean, I will for my customers, but I personally don't believe in them. And maybe I'll do a video on why at some point. But that's my feelings on that are based heavily on something that Dr. Bruce Chubb told me, and he had a very good point. For reference, his doctorate is in electrical engineering. He designed circuit boards. He has circuit boards in space, so I have faith that he has a clue what he's talking about. Alright, so step one is we're going to get in here and we're going to pop this old beauty open. That little black thing right there is actually part of the frame, and it is a locking tab. So the way you get these open is prying up on both sides to remove from those locking tabs. Now sometimes I can do this with just my fingernails. No, not today though. So we will grab ourselves a screwdriver of appropriate size, like so. We'll just reach under there and go pop. And then we flip it around to the other side, and without pushing the other one down, go pop. Oh, maybe. There we go, pop. And now she comes right loose, and we get into the heart of the matter. A few things we got to do here. Motor has to be isolated from the frame because currently the left-hand rail is coming off of the frame and going straight to the motor. The right-hand rail comes up through these metal pieces on the side of the truck, through this piece of metal, and into the top of the motor, and also into the LED, or not LED, sorry, the incandescent bulb, which also gets its other half from the frame. This whole support goes away. The incandescent bulb goes in the garbage. We're going to go to LEDs, and of course this band on the motor is going to be the first thing that we get rid of because it's junk. It's useless. It's also steel, and it rusts. This one's not very bad. In fact, this has barely got any corrosion at all inside of this locomotive, but I have seen them where this whole bar is just a solid piece of rust, as well as this bar here, because they're both steel and they both rust. These are steel also. In fact, the back truck, the rear truck, you can see nice spot of rust right there. Alright, so we'll just get rid of that piece of steel because it is useless. And what I do for this one with the light is I take my handy dandy pliers and I grip it. Let me move the shell out of the way so I don't break anything. I grip it right here on the front and I just wiggle it side to side. And it takes a moment. There we go. And it starts breaking loose. And I twist it around a little bit and just keep wiggling and apparently shake the workbench enough that I cause a small avalanche. Too many things stacked off to the left here. But eventually it starts coming loose and you can get it off of here. Sometimes it's a little more stubborn than others. This one's a little more on the stubborn side. There's one side busted off, and there we go. So it's just this hole basically on that nub right in there. And so we get that sucker off, and it goes in the junk pile. Alright, this has already been converted to KDs, so we're not going to worry about that. So it is literally just an electrical conversion, which means the next step is getting that motor out so that we can isolate it from the frame. So I just take a smaller, actually I don't want a smaller, we'll put that back in the, I take my normal PH1? Yes, PH1 screwdriver and push from the bottom on these little rubber nubs. Now here's something to know about these old units, and this one's suffering from it. This rubber gets very brittle, so I am going to have to replace these. And I'm not sure I currently have any. I will have to, off camera, go and look through my stock. But for our purposes for right now, we'll just take them off. And the reason that it's bad that they're brittle is because they will eventually just snap. This one's still got a little bit of pliability to it, but nothing like it should. The replacements for these are no longer white. They're black, and they're made of a slightly different material, and they last a lot longer. I do recommend that if you have an old Athearn unit like this and you're going to do any work to it where you got to take the motor out, buy yourself a set of replacements ahead of time. I didn't make sure that I had a set for this because it was kind of a spur of the moment thing. I'm actually doing this as a freebie. Like I said, the gentleman who owns this is a friend of mine, and this decoder was free to me as a salvage part. So I'm just giving it to him, and the work I'm doing for free to work on my YouTube channel here and show people how to do these things. And, of course, also because he's my friend. Alright, so we're gonna... I use my tweezers for this, and I keep my thumb here. So there's this end of the motor, okay? You want this end, and you want to remove this, and very, very carefully, there we go, and I keep my thumb here so it doesn't pop off, because I want to slowly release the tension. There's a spring under there that I don't want to lose. Replacements are available, but they're kind of a pain to get right now. Global supply chain problems and all that. Now I take my old rail nippers that have damaged jaws, and I come in here and I bend these tabs up that were meant to rub on that that slot in the frame, and I bend them upwards, and then I'm going to nip them right off. So we're going to hold on to that with our thumb so it doesn't shoot across the room. Beautiful. And same for the other one. We're going to hold on to it so it doesn't shoot across the room. Come on. Oh, that did not want to cut. These poor old rail nippers, they're getting, the blades on them are getting to be pretty rough. So there's that. It does leave two little spiky pieces here that we want to get rid of, which I do just by coming in here with my pliers and mashing them down until they're not a problem anymore. There's a section inside the jaws of your pliers behind the teeth, but before the cutting blade, that's usually flat. I start with the toothed area, and then I work it back into that flat area. And then, once those are all flattened back out, I can rub my thumb across here, and there's actually a little bit of, I don't know if it's damage or what, but a little nub at the back that came from the factory that way. So I'll come in and I'll put it in the flat part of the pliers jaws and flatten that out as well. Now I have a good flat surface. Oh, nope. The other end. I'm guessing that by the time they get around to making this one, the die that would punch these out was getting pretty worn out. So we'll do the same on the other end. There we go. Nothing's catching on my thumb anymore. And if it's not catching on my thumb, it's also not going to catch on the Kapton tape that we're going to put under here to isolate that. So now that that's done, we can put it back on the motor. There are two different ends. There's this S-shaped end, and there's this end that's more of a C-shape. The C-shape goes to the rear of the motor, away from the spring. Alright, there we go. Now another thing that we're going to want to do before we put this back together is clean that. That's a lot of carbon. The springs on top and bottom of the motor actually hold in the brushes, the carbon brushes. You can see one sticking through right there. Maybe. Yeah, you can just barely see it. You can see them sticking through. I think this is called a commutator. I'm not an expert on motors. Don't have to be, thankfully. But I do know that that needs cleaned. That's a lot of carbon buildup, and that will make the motor a lot less efficient, and it'll draw more current. So we will deal with that before we put her back together. For now, we're done with the motor. Set it aside. We need our Kapton tape, which of course I put just out of reach, and I had to really stretch for it. So we get in here, and we just get ourselves a length of Kapton tape. Put that with our knife and lay that right. Whoop, try to get it a little better centered than I just did. There we go. Lay that in there with our knife, or I mean with our finger. And then we come back with our knife and punch out where the holes are. All I do is break it. I don't actually try to remove the material. I just break that tension. Now you're wondering, why don't I just use a skinnier strip? And I used to. I actually have a significantly skinnier roll here. But the problem was, that it just didn't have enough grip area to stay on the chassis. So I even come back in here and I rub this in to make it stay better. Kapton tape is great for electrical insulation. It's very thin, also very high heat resistant. So if your motor gets hot, it won't melt this like it could possibly do to PVC, standard electrical tape, your black electrical tape, you might call it. So it's a far superior choice for our locomotives. And it's great, but it's not always the stickiest tape. So you really want to make sure you've got it down good. But with the little slits that I cut in, when you put the motor back in, it should just push that Kapton tape. A little hard to do with your fingers. There you go. Right out of the way. So it'll just sit down in there, and that actually will help because it grips the edge of the tape. It'll help hold it in there. So you're getting a double benefit that way. All right, toss those aside. Next thing we need to do is take our handy dandy sanding stick and whoops, apparently bend the heck out of that. That's weaker than I've ever seen them. We just want to take that little bit of surface rust off. But we also want to scuff these up because I do solder to these. And I'm going to tell you a little secret. Solder doesn't stick very well to steel, even once you've scuffed it up like this, but scuffing it up does help. Alright, blow any dust away. Alright, looks good. So the other thing that you can do, and that I usually do, is rather than trying to... So, let me take a step back. There used to be conversion kits for these that had basically treated this like a spade connector. So it had the female spade connector and would slide right on over this. And it had two, so it would do both trucks. And then it had a screw and instructions on where to tap the frame. So you had to drill the frame out and then run a tap through it for a screw. Then the screw went in there along with a little, I think it was brass? No, copper. It was a little copper ring with a tab sticking off of it that you soldered to get your connection from the frame. Well, rather than counting on that, which counts on a friction plate underneath the trucks, or on top of the trucks underneath this crossbar of the frame, making good contact, rather than count on that, I actually started soldering to this little ring right down here on the side of the truck. And I would do that to both trucks and get my other rail that way. And that's what we're going to do on this unit. But first, I have to pause the recording, turn on the soldering iron, let it get warm while I take some dogs outside to go to the bathroom. I shall return. Hello again, everyone. I'm going to have to apologize for what will be a disjointed video. I had real life things intervene and cause me to delay working on this. And I have done some things off camera. For example, I have remounted the motor using the original motor mount pads. I could not find any in my stash, and it's not something I can easily get right now. So just since there is some pliability left in the originals, I did put them back in. They're easy to change in the future, so it's not really a big deal. I've also removed both trucks, gotten the wires soldered onto them, and reinstalled the rear truck. I've also soldered both motor leads on before I remounted the motor, having removed all of the leads from the decoder itself just to facilitate installation easier. Now I have the second truck ready to go. As you can see, I have solder already here, and I don't know how well the camera will pick it up. Oh, it looks like pretty good. Let's grab something to point with here. You can see I have solder on that ring that I was talking about previously that I will solder this black wire to, just as I have done on the rear truck. So I thought we could do that part together, and that way you guys can see that that's what I really do to make an excellent connection. And it's just as simple as that. Give it a couple gentle tugs, make sure it's nice and snug, which it is. Get the truck oriented the right way, and then we can reinstall it in the frame. And the first thing you do is actually feed the wire through, because otherwise it can be very much a pain. Oops, and I put it through the wrong space. So you got to put it through the same space as the this metal piece goes through, and then we just get it centered so that it sits down on its mounting peg. Then the rest of reinstallation is as simple as getting the drive shaft back together. I use this pair of tweezers to get these bushings correct, and then we just slip the cover back on. Come on, if it'll snap down, of course. There we go. So now both trucks are fully reinstalled, and of course the black wire decided to try to run away, so we'll pull that back through. I did also put capped on tape across the metal, the copper strip here on top of the motor, and the reason for that is because that's where the decoder mounts, which I mount with servo tape, and the piece of servo tape is not long enough to cover the bare metal. But let's grab our handy knife here, and I do a little bit narrower than the decoder. I can do this by eye because I've done it so many times now, and I just get a good starting cut. I don't cut all the way through, because then I come back after folding it over and cut the rest of the way through. Now, the reason that I do that is so that I don't cut the next layer down. Alright, then we just install that over the motor and use our knife here to, oops, get out of the way, wires. Come on, wires, behave. Yeah, right. To get the backing started. Once the backing is started, I come in with the tweezers, and I'm going to have to do this opposite-handed. It's a good thing I'm pretty ambidextrous. I just peel it away using my finger on the other hand to hold that down. Alright, now that that's ready, we can install the decoder. I try to get it lined up so that the ends of the decoder, both ends of the decoder, are approximately the same distance from the ends of the flywheel, which with this decoder, which is almost as long as the motor including flywheels, it's pretty close. So give you a side-on view there. So we get that done. Now, one thing that I've learned from Dr. Bruce Chubb is that he's a doctor in electronics, if I haven't mentioned him before in this video, is that you want to use the pads on just one end of the decoder and run both wires of that color to that pad. So we'll start with the black wires because I have both already on, and it's just a matter of trim to length. Strip. Bring our solder in here, and tin, which I need to re-wet the tip. There we go. Get a good tin going. And then do the same for the other length of wire. Snip. Alright, once both lengths are stripped like that, I can try, and this can sometimes take a couple of tries depending on how finicky it wants to be, and get them both to solder without pulling one off. Like that. Like I said, sometimes it can be a little finicky. One trick that I use frequently to make this go a little easier is to use the tweezers and get in there so that I can, yep, there we go. They are now both attached. So that is, the black wires done. Now I do leave a little bit of length in both wires, and that is to give the trucks free range. I probably left a little too much on this rear wire, but it's not going to hurt anything, so I'm not going to take it back apart and trim it up more. Alright. And of course, I fed these through the wrong side. That's okay. We can just cross feed them underneath the decoder here. I couldn't remember which side, and then when I looked at the decoder, I apparently looked at it backwards. I'm human. I make mistakes, just like anybody else. So we get them down to the motor pads here, and I trim them both long enough that they can reach the farthest motor pad, so that if I do have them backwards, I'm 99% certain I don't, but if I do, it's as easy as swapping them on the decoder. Alright. And then we'll just grab our handy dandy tweezers here so that I don't burn my fingers. Doesn't feel good to do that. And put the orange on motor plus. Beautiful. Put the gray onto motor minus. Again, beautiful. So that is the motor all hooked up. We do not want the gray wire to be wedged in there like that, so pull it out. And now I need another piece of red wire. Hopefully I have one handy here. And you'll see sometimes I hold the wire and bring it to the solder, sometimes I hold the solder and bring it to the wire, and sometimes I hold both. It all depends on the circumstances of what I am doing at the time. It's whatever works is what I do. Alright, good connection there. And I have a pretty strong connection there, thanks to scuffing it up previously with the sanding stick. I really do recommend that if you are going to hardwire one of these. It's significantly better than most other methods. At least if you make good solder joints anyway. Which I certainly try to. I certainly try. Alright, so we'll plug that guy onto there. And we need to shorten this up. I actually could have gotten both pieces out of this one wire and didn't realize it. Oh well. Live and learn. And this will be another case where I hold both. I learned this little technique from bigclive.com. You use your thumb and your index finger to hold the solder, and use your ring and middle fingers to hold the wire. or circuit board or whatever it happens to be that you're soldering. Alright. Oops, sorry, I bumped the camera. Still not really used to this whole filming thing. Alright, that one was a little bit better than the other side. Makes me want to redo this one. Yeah, that's the danger of trying to redo it. It just comes apart again. Beautiful. Alright, couple tugs, make sure everything's secure, which it is. Now that's basic decoder. So I'm going to pause the video here for a moment, get this up on the track, make sure I have it plugged into actual power and not programming, and we will see if we can get it with a test run. Actually, I'm going to make sure it's on programming first, that way I can read the address, because this is a salvage decoder. I don't know if it's address 3 currently or not. I shall return momentarily. Okay, I have reset the decoder to address 3 and checked. We have motion and it is in the correct directions. With that done, I can continue to work on the further stages of this installation. I'm going to pause once again and get readjusted for continuing work. Alright, so now that we've tested the motor, made sure that everything works correctly, it's time to move on to getting the lighting going. Here's my resistors, so I'm going to quickly tin those just off camera here. And now, of course, I need to remind myself which pad is which. Alright, so that one for the front, and same side for the rear. You can tell on Soundtrack's decoders because the positive pad is rounded at the end closest to the board, whereas all the other pads on all the other outputs or inputs are all square edged. So only the common positive, which we can't use because it's not the correct voltage. We have to create our own common positive off the 14 volt pad back here. I'm pretty sure I mentioned that already, but we will take our wonderful resistor here and we're just going to solder it directly. Beautiful. Now I'm going to do something I don't normally do. I'm going to leave the entire leg here. And I'm going to do the same thing on the rear, because this particular unit has something I have never seen before. I've done, I don't know, 2, 3, maybe even 400 blue box locomotives in the 18 or so years that I've been doing this professionally, and I have never seen this. Inside, right there, whoop, right there, that's a lens. That is a plastic lens for a light. I am used to the 1.5 volt bulbs being directly inside of the housing here and having to get those out and then put in 0402 LEDs mounted with canopy glue to form a lens using the glue. However, that's not going to work in this situation. So, I'm thinking of doing a standard 3mm LED just sitting right behind the housing inside, including down in the nose. I will have to create a light baffle for it in the nose because we don't want it shining back up into the cab. And so I have little tricks on how to do that too. But yeah, this is completely different than what I'm used to. Additionally, this unit, being a CB&Q GP35, has a piled gyrolight housing here. The upper lens is supposed to be a white light, the lower lens is supposed to be a red light. However, that's also unfortunately got a huge plastic lens that includes the number board lens on it. I'm not going to light anything up here. This is a very cheap unit, and I'm not being paid to do this job, so not going to spend a whole lot of time on it. Otherwise, I would get that whole lens assembly out, which is going to be difficult. I tried taking this nose headlight out, and that's a tiny little one, and it will not come out. It's glued. So I would have to try to figure out how to get it removed with the glue and everything included. But yeah, if I was doing this for a paying customer who wanted this done correctly, I would actually remove that lens, cut that piece of the lens out, put a white 0402 in top and a red one in the bottom, and then wire them up both separately so that they can be turned on separately. Thankfully, if my friend decides he wants that done, this decoder will support it. I do have 2 function outputs here so that I can have that capability by putting the white one on F5 and the red one on F6, since this unit doesn't have ditch lights. Alright, so with those installed, I need to find headlights because my package is missing. That's concerning. Alright, I shall return shortly when I have found where I misplaced the headlights at. Okay, so I've found 2 suitable LEDs. These are salvaged LEDs, but still working, as we can see by the quick battery test here. So I am going to solder the negative leads. I'm going to actually start with the other one. Just a quick double check. Yep. I'm going to solder the negative leads to those from the resistors. Alright. Looks like a joint there, and I gotta flip the unit around. Just move the shell out of the way. Actually, no, put that back and get it lined up again. I have that there to give me a rough idea of how far away I need to be. The leads on this one need straightened, which is quick work for our little pair of pliers here. And then we can get a good solid joint with this one as well. Beautiful. Alright. And then I want some blue wire out of my pile I've got going on right here. And now we can move the shell out of the way. First thing we're going to do is tin the 14 volt pad there, which is actually a through hole. Goes through to the other side of the board. And off shot here, I am tinning one of the trimmings from the ends of the resistor that we put onto the board. And I'm actually going to, let's see if I can spin this in such a way that you guys can see without melting any wire insulation. We're going to put that in there as a, there we go. Trim that down. And this one blue wire here is very stiff, so I'm going to trade it for a different one. There we go. And we're going to get the ends of these ready. Okay. So I've twisted and soldered the ends together here just to make it simpler to attach. And I'm going to tin our little post that I made. And now we're going to just attach. I'm sure my big ol' hand is in the way, so I'll have to show you when I'm done. There we go. We just attached that to the board, and now I just figure out which wire I want to go which direction. And it's the same as all the other wires. We trim, we tin, and then we attach. There we go. Now you'll notice I'm not putting heat shrink on these. I normally would, but I'm not sure that this is going to exactly work out the way I want it to, so I want to leave myself options to easily take it back apart. Plus there's nothing other than its own negative lead that it can touch easily, and it shouldn't be able to do that. If it does, I'm doing something very wrong. Wouldn't be the first time, won't be the last time. A lot of working on locomotives, especially ones you've never seen before, is just figuring it out. Okay. So with those installed, and I flipped this one around when I installed it, didn't even notice. So let's fix that. Oops. Gotta hold still for a moment until the solder cools. There we go. Now I should be able to put the shell on. And grab our old knife pry bar there. Voila. Alright, I'm going to stick that on the track. Grab my throttle and turn on the headlight. Alright, so there's the front headlight on. Direction key and rear headlight is also on. Perfect. So our headlights are working. But I did realize that I'm not going to be able to build that baffle like I wanted to for the front headlight. So I'm going to have to go with an alternate solution. It's not ideal because it won't block 100% of the stray light. But that's okay. We'll make it work. And that solution is a bit of heat shrink. So if I slide, oh, wrong size. Let me grab my heat shrink bin here and grab another size up. Away. So we can slide a bit of heat shrink right over the whole thing here, and that will allow us to prevent most of the sideways light. Alright, get that up there. So once I've got them on in the position that I like, we're just going to give them a very brief shrink. just enough to make them grip the bulbs, the LEDs. And then we can put our shell back on again. And once more with the headlight. And if we if we reposition the camera, I'm tired. It's late. I need to go to bed. I really gotta stop staying up late doing this stuff, but I love it too much. I don't know how well it's picking it up on the camera, but there is light shining down here onto the track below the unit, which isn't ideal. But there's not a whole lot I can do about it with the current design. So let's put that back there. And that's where we're going to end this first episode on this unit. I was going to finish the entire unit. However, the speaker I ordered for it has not yet arrived. So I want to get this video out because I did promise it to someone on Facebook so that they can see how I install a decoder in an old blue box style unit. Thank you all for watching, and I look forward to seeing you when we put the speaker in and finish this unit up.